All right, let's continue our lesson 1, percent of change. So today you will be able to use proportional relationships to solve percent of change problems, use estimation and reasoning to verify that the percent of change between two quantities is reasonable, and use proportional reasoning to find the percent of change in real-world situations. So we're going to look at percent of change. Again, we just did all our proportional stuff. We looked at percent of increase yesterday. Now we're going to do percent of decrease today. So your warm-up. So write each decimal as a percent. Go ahead and pause your video. Come back when you are done. All right, so let's go ahead and solve these. 0.02. Anytime I'm solving a decimal, it's 0.02, and I have to turn it into a percent. I multiply by 100. Multiplying by 100 means I move my decimal point 2 places to the right. So if I move that 2 places to the right and I write this as 2.0, it's 2%. I could check that by doing 0.02 times 100. I don't need to do my zero multiplications because I know that's all 0. 1 times 2 is 2. 1 times 0 and 0, I don't need this. I have 1, 2 decimal point places. 1, 2, right here. I got the equivalent to, all right, 0.1 times 100. Remember, 1, 2, I have to add a 0. So that's going to be 10%. Let's double check. 0.1 times 1. Uh-oh, I don't have enough space, do I? So if I add a 0 up here, I know I don't need these zeros. 1 times 0 is 0. 1 times 1 is 1. 1, 2. 1, 2. So I got 10. Could also write this as 100 times 0.1. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. I have 1 decimal point. That is also 10. 0.87 times 100. Move my decimal point 2 to the right. Gives me 87%. Double check my math. 0.87 times 100. My zeros. 1 times 7 is 7. 1 times 8 is 8. I have 2 decimal places. 1, 2. Gives me my 87. 1.25 as a percent. So I've multiplied by 100. This one's a little different. I already have a whole number. So I'm going to move my decimal 1, 2. That gives me 125%. Ooh, let's double check and make sure we did that right. 1.25 times 100. Well, we know we don't have to worry about our zeros. 1 times 5 is 5. 1 times 2 is 2. 1 times 1 is 1. I still have 2 decimal points. 1, 2. So that gives me my 125. 125. That is a valid percent. Anytime I have more than a whole, more than 1, I'm going to have a percent greater than 100. And number 5, Malik's proportion of wins in Among Us was 0.65. What is the percent of wins that he had? So we're going to do 0.65 times 100. Move our decimal point 2. Gives us 65%. Double check our math. 0.65 times 100. Put my zeros. 1 times 1 or 1 times 5 is 5. 1 times 6 is 6. 1, 2 decimal points. 1, 2 gives me 65. All right, so let's review the vocabulary we're using. We are using percent of change as a ratio that compares in change to the quantity to the original amount. So you put your amount of change over the original amount. Example, the cost of an item goes from $20 to $25. The amount of change is $5. So that amount of change is how much is in between. So $5 is 25% of the original amount. So a non-example would be it not changing, the price not changing. Decrease is how much a price goes down, or a negative percent of change. And percent of increase that we did yesterday is a positive percent of change, or how much it goes up. So we're going to touch on percent of increase just a little bit, and then we're going to move into percent of decrease. So we're still working on how can you use percent to describe a change when quantity increases or decreases. That's what we're still looking at. Remember, percent of increase is when the original amount is increased. So that original money you spent or that original number of things is increased. So, internet prices. Yesterday we learned about the price of a monthly internet plan increased from $36 to $45. You can use a bar diagram to determine the increase, which is what we did. Remember, we used all our pieces, used all our pieces to model that $45 is now 125% or a 25% increase. So 100 is divided by 4, gives us our 25. Well, let's look at another way to solve that. So identify the part in the whole. So our original amount was $36. That is our whole. That is the entirety of the number we're working with. The new amount is 45, is the whole plus the part. And the increase is that part. So if you think about it like fractions, your original amount is going to be your whole. Your increase or your decrease, as we'll learn later, is the part. And then the whole plus the part or the whole minus the part is going to be your new amount. So find the percent. So then you're going to write it part over whole. So it's going to be your part, $9, over your whole, 36. Divide 0.25. Write it as a ratio. Remember, 0.25, this is 25 hundredths. You can write that as a fraction, 25 over 100. And then 25 over 100 is 25%. So this is one method. If the bar graph was confusing, try this way. So percent of decrease. Let's do some exploring with percent of decrease. A sleeping bag sale now. A sleeping bag at a store sells for $60. The manager changes the price to $45. So how much does the price decrease? Well, in order to figure that out, we need to take $60 and subtract $45. We always take the larger subtracting the smaller. It's just how subtraction works. So 65 minus 45, or 60 minus 45 is going to be 15. So missed a letter. Our percent of decrease here, or our cost of decrease is $15. The manager saved us $15. So knowing that, let's go look at our next slide. All right, so you know the price of the decrease. You know the price decreases by $15. How can you use the bar diagram to find the percent that corresponds to 15? Well, I can do a couple things. I could divide 60 by 15, which, if I were to write that out, would be, so we're writing out 60 divided by 15. All right, so 15 times 2 is going to be 30. So it's got to be times an even number. So let's try 4. 4 times 5 is 20. Carry my 2. 4 times 1 is 4 plus 2 is 60. So we now know that 60 divided by 15 is 4. So I can move 4 tiles onto my bar here. 2. Please forgive me that they are not even, but you get the point. All right, so we have 4 tiles, 4 sections, each $15. Now, how do I figure out what percent that is? Well, I have to take my 100 and divide it by how many sections So we know we have 4 sections. So if I take 100 divided by 4, well, 4 goes into 10, 2 times 4 is 8, 10 minus 8 is 2, bring down my 0, 4 goes into 25 times, 5 times 4 is 20, 0, so it's going to be 25%. So each one of these blocks is going to be 25% of the whole. So all 4, 25, 50, 75, 100 equal the whole. So 60 divided by 15 is 4. The bar is divided into 4 equal sections. Each section represents $15. Again, then 100 divided by 4 is 25. Each section represents 25. So how much did the price decrease by? Well, it decreased by a total of 25%. That's 25%. because the $15 was 25%. So let's look here. So how can I show the new price on the bar? Well, I still know that all of my squares are 15%. Or $15. New price of 45. So 15 plus 15 is 30 plus another 15 is 45. So I'm going to move 1, 2, and 3. So that's now $45 there. So let's look. So we've moved our pieces. That 45 is 75%. So what is it is now on? It is 25% off, or it is on sale for 75% of the original price. So percent of decrease is when the original amount is decreased. So let's do another one. The bar diagram again. At the beginning of a chemistry experiment, the volume of the liquid in a container was 25.2 milliliters. During this experiment, the volume dropped to 18 9/10 milliliters. Draw a bar to represent the original volume. Because the original volume is the whole, label the bar as 100%. So here's our bar. This is what we're going to work with. The volume decreased from 25.2 milliliters to 18.9 milliliters, which is a decrease of 6.3. So we're going to divide 25.2 by 6.3, and it equals 4. So I can drag 1, 2, 3, and 4 tiles over, and that's my full bar. So each section is 6.3 milliliters, and because there are 4 sections, 100 is divided by 4, which gives me 25, 50, and 75. Each section represents 25%. So then we have to figure out how many of those equals the 18.9. Well, it's 3. If I do 6.3 plus 6.3 plus 6.3, I get to 18.9. So each section represents 25% of the whole, 25.2 milliliters. The ending volume of the liquid was 18.9 milliliters. What is the percent decrease in the volume of liquid? Well, we went down one whole set, so it decreased by 25%. We can also do ratios. So I put the story up there in blue. All right. Oops. And I forgot to change a couple numbers. All right. So identify the part. So our whole is the 25.2. Our part is the 6.3 decrease. And our new amount is 18.9. So we're going to take our part over our whole, 6.3 over 25.2 is, and then you divide it. It's 0.25. So remember, your new amount is the whole minus the part. You turn your 25 over 0.25 into a fraction, 25 over 100, and get 25%. If this is easier for you, do it this way. Your exit ticket for today. Make sure you answer this question here. When resting, a spring measures 73.3 milliliters. When the spring is compressed, it measures 51.29 millimeters. Find the percent of decrease in the length of the spring. Round to the nearest percent if necessary. Use any strategy. Show your work. So you saw how I showed my work. You can do something similar like that. And then your homework. There are 7 questions and a bonus question. The top of the form tells you where they're at in your workbook. Make sure that you complete all of these questions.